Welcome to this presentation on the expansion of the IWBC Advanced Treatment Expansion. We are Sixth Sense Solutions, and today we will take you through the following fields in hopes to give you a better understanding of the multi-million-dollar efforts to optimize usage of Tijuana's wastewater effluent.
So to start, I want to talk about Tijuana River crisis. It has been going on for at least 50 years between both the United States and Mexico, since the Tijuana River flows between country lines. The Tijuana River is impacted by outdated wastewater treatment systems in Tijuana and a lack of enforcement within the industry that pollutes the river even more. On top of all of that, the sprawling neighborhoods within Tijuana are underdeveloped and lack plumbing. Finally, the South Bay International Wastewater Treatment Plant is currently treating the influent that is coming across the border, but it cannot handle the flows. Currently, the capacity of the treatment plant is 25 million gallons per day, but during rainy events, that flow can reach a maximum of 1 billion gallons per day. Our expansion of the treatment plant hopes to treat 50 million gallons per day with a peak flow of approximately 75 million gallons per day. Finally, the project objectives are aimed to reduce the transboundary flow that cause public health impacts and environmental impacts. Within Tijuana, we hope to ensure water reuse through the reduced dependency on the Colorado River, which is the main water source for Tijuana currently. The treated effluent can be used and will be used for landscape irrigation and groundwater replenishment between both countries. Finally, through our next section, the nutrient removal process is the first step on our treatment train.
Going over the importance of nutrient removal, first and foremost, the most important reason for nutrient removal is the prevention of eutrophication and also the long-term stability of environmental buffers such as groundwater replenishment are in danger without nutrient removal. A sustained presence of nitrogen in our water systems has been proven extremely unsafe for humans, demonstrating that nitrogen monitoring requires continued monitoring. And we'll be choosing a Kruger's anaerobic anoxic A squared over 2 process, which will produce a figure like the one shown below.
Moving forward, we're going to talk about the design for the advanced water purification. So the first step is going to be membrane filtration, and in this step, a membrane material of polyvinyl iodine fluoride was selected for this design due to its ability to withstand aggressive cleaning and disinfecting, high range in pH, and both a high chemical and high fouling resistance. For the modules, an outside-in configuration was selected. And a feed flow rate of 24.67 million gallons per day is required to supply the 20 million gallons per day for landscape irrigation. For this design, a total of 16 skids, each with 76 modules, is required, totaling in a needed land area of 818 square feet.
Moving on from membrane filtration, we're going to go to reverse osmosis. And just some summary of reverse osmosis. It's the process of forcing water through a semi-permeable membrane using pressure to overcome the osmotic pressure. So we're going to start by taking the 22.2 million gallon per day feed flow rate from our membrane filtration step in order to get the 20 milligrams per day or 20 million gallons per day for irrigation. So during our process, we were able to calculate a total of 694 Presso vessels are needed in order to handle that flow. And so we decided to round up to 700 so that we could have 10 equal stages. And each stage is one array. And we decided it's going to be a 10 by 7 array, making 70 pressure vessels per stage. And we were able to calculate that total area would be 157,726 meters squared, And the land area of one of those pressure vessels is 235.5 feet squared, taking up a total land area of 2,730 feet squared. Moving on.
For the UV disinfection, our design was based off of a log 6 removal of the MS2 bacteriophage. In this design, 1,320 low pressure, low intensity UV lamps at a wavelength of 254 nanometers are within 110 banks on an approximate land area totaling in 462 square feet. The UV dosage required is going to be 131.36 millijoules per square meter, and an exposure time of 26.3 seconds was required.
Using advanced oxidation alongside UV disinfection is a more effective way to produce high-quality, safe water. While both methods can achieve 6-log pathogen removal, advanced oxidation also breaks down tough hazards like 1,4-dioxane, a likely carcinogen that UV alone can't remove effectively. AOPS typically combine hydrogen peroxide with low-pressure UV light to generate hydroxyl radicals which destroy hard-to-remove pollutants. This method used in systems like San Diego's Pure Water faculty ensures a higher level of water purity and safety.
So the geographical layout of our three systems will be in the northwest corner of the current water treatment plant, and the total land area that will be needed is 4,010 square feet.
Alrighty. Thanks, Alex. We will now move the discussion to landscape irrigation, the logistical considerations of our project, as well as the strides our project looks to make in sustainability. Given the parameters of the landscape area, including vegetation with a moderate density and high microclimate factor, the landscape area was calculated with these considerations in mind. Following the procedure outlined in Chapter 18 of the water reuse text, a total water volume of around 27.6 million meters cubed is used, in addition to a summed hydraulic loading rate. The result is a total landscape irrigation area of 8,700 hectares. The reused water will sustainably serve Tijuana golf courses, parks, and sports stadiums for years to come.
Going over the logistical considerations, we'll be using the surface application method for groundwater replenishment, which applies the recharge water to a spreading area. And currently, potable water reuse is not the focus of this project and is not possible because the Tijuana River exceeds typical municipal wastewater in terms of contamination. The main goal is for wastewater treatment and environmental protection. And with limited public support, the public's perception is also another obstacle to surpass before potable water reuse would be viable.
Okay, moving on to sustainability. So we designed our project with the three components of sustainability in mind, those being the environment, the economic factors, and the social factors. So environmentally, by cleaning up and using this advanced process to get rid of all the pollutants down to the nanograms, we are able to produce and release a cleaner water back into the river and out into the ocean. This allows the ecosystems to rebuild and be healthier for years to come. And economically, our project is able to offer new jobs in building the plant, operating the plant, maintaining the plant, as well as the irrigation process of laying all the pipes and designing that whole process to make sure that runs effectively. And socially, this project is helping us build connections with Mexico, as well as helping the communities have a better livelihood down the river and by the ocean where the water was once being dumped. And our project was also designed with 4 sustainability development goals. Goal 6, Goal 9, Goal 14, and Goal 15. Goal 6 is the clean water and sanitation goal, And our goal or our project was able to follow that by creating clean, even cleaner water than before and producing that out into the river and ocean. And then goal 9, industry, innovation, and infrastructure. We were able to use this new innovative technology to clean our waters, and we upgraded our plant to an even better system. And then goal 14 and 15, life under the water and life on land. We're helping the ecosystems rebuild. The people around these waters are going to be healthier because there's less pollutants, less air pollution. And so our project did a good way, and we're helping a thriving community for many years to come.
The South Bay International Wastewater Treatment Plant upgrade project offers a strong solution to a long-standing environmental and public health issue at the US-Mexico border. By expanding capacity from 25 to 50 mgd, it addresses the flow of untreated wastewater from the Tijuana River into the Pacific Ocean. The upgraded system uses multiple treatment stages: nutrient removal, membrane filtration, reverse osmosis, and UV disinfection to ensure the reclaimed water is safe for reuse. The A2O process removes nitrogen and phosphorus to prevent nutrient pollution. The clean water will be reused for landscape irrigation in Tijuana, reducing the city's dependence on distant freshwater supplies. Moving forward, there are several opportunities to strengthen and expand the project. Future work should include continuous water quality monitoring to improve system performance and ensure compliance with safety standards. It would also be valuable to study the long-term effects of reclaimed water use on local aquifers and landscapes. Finally, collaboration between U.S. and Mexican agencies will be essential to secure funding and ensure the project's long-term success across the border region.
Thank you for listening to our presentation, and we hope you use our design for the expansion project.